filling the cracks. So what's special about the calm ice stream? Why is this happening there?
The key seems to be the water underneath this particular ice stream. It's surprisingly cold, only about zero point 0.3 degrees Celsius above freezing point, with an even colder layer, just tiny fractions of a degree above freezing, right below the ice itself.
Ah, okay.
And this super cold water is significantly slowing down the melting rate. They estimate it's melting at maybe 26 centimeters per year. Compare that to the nearby Thwaites Glacier, the Doomsday Glacier, where much warmer water is causing melt rates of 5 to 40 meters per year. A
Wow.
huge difference.
Wow, meters versus centimeters. That's dramatic. So the calm stream is kind of self-repairing itself because of this cold water.
In a way, yeah. The Science News article also points out that the seabed beneath Calm is shallower. This prevents it from being exposed to those deeper, warmer ocean currents that are hitting Thwaites and causing so much trouble there.
Okay.
And this refreezing process, it might actually make the ice shelf there more resistant to calving, breaking off icebergs,
Yeah.
potentially more stable than we previously thought.
As long as that cold water stays underneath it.
Exactly, as long as it remains bathed in cold water. It's a fascinating glimpse into the complexity, isn't it? There are even these weird vertical grooves in the crevasse walls that might be formed by concentrated brine being pushed out during the refreezing.
That's incredible. A really complex local process happening there. It really highlights that Antarctica isn't just one big block of ice acting uniformly, right? Different regions are responding very differently.
Absolutely. Local geography, ocean currents,
Mm-hmm.
they play a huge role. Okay,
Yeah.
so moving from the specifics of ice back to the big picture sea level rise.
Yeah.
What are the global trends and projections telling us based on our sources?
Right, the main event for many people. The Jones-Chant analysis of the IPCC report lays it out pretty clearly. Global mean sea level, GMSL, has risen by about 0.20 meters, that's 20 centimeters, or roughly 8 inches since 1901. And crucially, the rate of that rise is accelerating.
Accelerating, that's the key word.
Yeah, in fact, the report states with high confidence that the rate of sea level rise during the 20th century was faster than any other century in at least the last 3,000 years. And it's been speeding up even more since the 1960s.
And the average rates themselves really illustrate this acceleration, don't they?
Yeah, they do. What were those numbers again?
It was around 1.73 millimeters per year in the early 20th century. Then it increased to about 1.87 millirere between 1971 and 2006. And then it really jumped to 3.69 millirere between 2006 and 2018. That's based on tide gauge data combined with satellite data later on.
Okay, so more than double the rate of the early 20th century in recent years.
Exactly. And the projections for the future by 2100 compared to the 1995-2014 average, well, they're also quite concerning.
What kind of rise are we potentially looking at by the end of the century?
Okay, so under a lower emissions pathway, that SSP 11.9 scenario, the projection is for a rise of about 0.38 meters, so 38 centimeters. The likely range is maybe 0.28 to 0.55 meters. But under a high emission scenario, SSP 58.5, the projection jumps significantly to 0.77 meters, with a likely range of 0.63 to 1.01 meters. So potentially over a meter of rise within this century in a high emissions world.
Over a meter. That's huge. And are these projections different from previous IPCC reports?
They are slightly higher than those in the AR5 report, but generally pretty consistent with the findings from the special report on oceans and cryosphere, the SROCC.
Okay. And we have this clear global picture of accelerating rise, but does it happen uniformly everywhere, or are there big regional differences?
There are definitely significant regional variations. Short-term ocean processes, land movement, ocean currents. They all influence local sea level. However, the IPCC expects that the signal of human-caused sea level rise will become evident in pretty much all regions by 2100, overriding some of that local variability.
And the main drivers haven't changed, right? It's still thermal expansion and melting ice.
That's right. The main drivers are still the thermal expansion of seawater as it warms up, the melting of glaciers all around the world, the melting of the big ice sheets in Greenland and Antarctica, and also changes in how much fresh water is stored on land, like in reservoirs or groundwater. And crucially, all these contributing factors are expected to continue well into the future.
So even if we, say, magically stopped all emissions tomorrow, would sea levels still keep rising for a while? Is there a lag?
Oh, absolutely. There's a significant lag. The IPCC states that global mean sea level will virtually certainly continue to increase until at least 2100, simply because these contributing factors, especially ocean heating and ice melt, have long response times. They're locked in to some extent.
Right. It takes time for the deep ocean to warm and for the ice sheets to fully react.
Exactly. And interestingly, if you look back at the period 1901 to 2018, about 40% of the sea level rise during that time was due to formal expansion and the melting of smaller mountain glaciers. But the contribution from the big ice sheets, particularly Greenland and Antarctica, has become increasingly important more recently. They contributed about 27% of the rise just between 2006 and 2018.
So the ice sheets are becoming a bigger piece of the puzzle, relatively speaking.
Yes, their contribution is accelerating. And as you mentioned earlier, the future behavior of these massive ice sheets is the single largest source of uncertainty in our future sea level rise predictions.
Especially Antarctica, right? That seems to be the big wild card.
That's exactly right. The potential for unexpectedly rapid melting or instability in parts of the Antarctic ice sheet is the biggest unknown. In fact, the AR6 projections include a nearly doubled contribution from Antarctic ice melt compared to the previous AR5 report. That's one reason why the overall sea level rise estimates for 2100 are slightly higher this time around.
Okay. What about those really scary multi-meter sea level rise scenarios, the ones that talk about ice cliff instability and things like that? How does the IPCC handle those?
Right, the marine ice cliff instability, or MICI hypothesis. This is the idea that if protective ice shelves collapse, the tall ice cliffs left behind could become unstable and collapse very rapidly, leading to extremely fast sea level rise. The AR6 report acknowledges this process, but states there's still low confidence in how likely it is or how quickly it might happen, mainly due to limited observational data and incomplete understanding of the physics involved.
So they didn't include it in their main likely range projections.
Correct. Those main projections, like the roughly 1-meter rise under high emissions by 2100, don't include MICI. However, the report does provide separate, more exploratory projections that do incorporate MICI models, often combined with structured expert judgment. And those projections indicate the potential for much, much higher sea level rise, especially under high emission scenarios, continuing beyond 2100, potentially several meters by 2300, or even more, in worst case, though, low likelihood scenarios.
Okay, so the main projections are worrying enough, but there's this additional layer of deep uncertainty about potentially much higher outcomes, especially in the longer term. That's sobering.
It is. The uncertainty, particularly for projections out to 2300 and beyond under high emissions, is huge. The range across different methods can be eightfold.
What about the nearer term, say by 2050? Did the report give figures for that? That's often more relevant for planning.
Yes, AR6 does provide sea level rise projections out to 2050 as well. Recognizing exactly that point is critical for long-term infrastructure decisions happening now. And even by 2050, we're already looking at a significant amount of unavoidable, committed sea level rise just due to past and present emissions. The report estimates that even if we had stopped all greenhouse gas emissions, like yesterday, we would still likely see an additional 0.7 to 1.1 meters of sea level rise by the year 2300, just from the warming already baked into the system.
Wow, up to a meter just from what we've already done.
Yeah. And the emissions pledges countries have made up to 2030, if implemented, would increase that committed rise by 2300 even further, to something like 0.8 to 1.4 meters.
So we've already locked in a considerable amount of future sea level rise, no matter what we do now. That's a really key takeaway, isn't
That
it?
absolutely is. There's a long-term commitment that's crucial to understand.
Okay. Now, as we touched on earlier, one of your sources, the article from Science Under Attack, offers a pretty different perspective on this whole sea level rise picture. What are the main arguments of this contrarian view?
Right. This article essentially pushes back against the mainstream scientific consensus. It argues that the evidence for an accelerating rate of sea level rise that's directly linked to human-caused global warming isn't as robust or reliable as often portrayed. It really emphasizes the complexities involved in accurately measuring global sea level over long periods. And it specifically raises questions about the transition, back in 1993, from relying solely on coastal tide gauges to incorporating satellite altimetry data.
So they're questioning the accuracy or maybe the interpretation of the more recent data that shows that faster rate of rise.
Yes, basically. While they acknowledge the long-term average rate, maybe 1.7 millimeters per year from 1901 to 2010, and they acknowledge the higher satellite error rate of around 3.2 millimeters per year since 1993, they suggest this latter figure might be an overestimate, or at least that there's significant uncertainty around it. More broadly, the article highlights that global sea level has naturally fluctuated quite a bit throughout the 20th century. They point to periods like between 1920 and 1950, where the rate of rise might have been higher than in other periods, like the decades immediately before or after.